Okay, let us discuss on the hydrology and precipitation. Very less members, only two watching now. As I said, I'll take exactly at 11:15. I'll take class at 11:15. 9 people. 7 members are there. I'll wait for another 1 or 2 minutes. I'll only wait for another 1 or 2 minutes. I said I'll take class at 11:15. Exactly 11:15. Already it's 11:15. No one is there. Only 6 members are there. 10 members. Fine. Khalil Ahmad, Sandeep, and Ashwini. Only 10 members are there. Even Indonesian people can also watch. Okay, my might be title is Ultimate Moment of Resistance, but I'll change. Okay, fine. Today we'll discuss on this will be our discussion on hydrology and precipitation. As I said, it is all about the name itself indicates hydrology. Okay, logy means logic, that is science. Okay, hydro means the water. Okay, the subject related to water. Okay, so hydrology is, okay, here he defines hydrology is the science that treats the waters on the earth, okay, their occurrence, circulation and distribution. Okay, so it is a natural process, obviously. Okay, you know, the how exactly the precipitation occurs. Okay, that easily you can okay, easily can study here. Okay, this is quite interesting subject. Okay, as it may be a theoretical, some part of the subject is theoretical, and remaining some calculations are also there. Okay, so the whole subject deals with from where you'll get the water and how it is get distributed. Okay, this is all about the hydrological, okay, cycle, as well as it's a distribution. Okay, here it is, definition he has given: hydrology, water, and this is a water science. Okay, hydro and logos, it is a water science. Okay, so it is again classified into different types. That is scientific hydrology, it mainly concerned with academic aspects. Okay, engineering hydrology, it concerned with engineering applications such as water estimation, precipitation, runoff, evaporation, evapotranspiration, transpiration, study of problems such as floods and droughts. Okay, so it is all about the prediction of rain, prediction of floods. Okay, and it's a distribution, how exactly it should be distributed. Okay, all these things will study here. Okay, for example, okay, now earlier, okay, last week we found we got a precipitation of around 30 to 50 mm in Bijapur city, right? Okay, so it happened. Okay, but earlier it was noticed. Okay, earlier we know that there is a chances of rain in Bijapur city, or Bijapur district. Okay, no, there is a many reasons of Vijaypur is under flood. Okay, you know the thing. Okay, this is studying these aspects. Okay, studying these aspects, we call it as the hydrology. Okay, it is concerned with the engineering application, estimation, water resource, study of precipitation and runoff, evaporation, evapotranspiration, study of problems and such as floods and droughts. Okay, so we can easily predict whether this time there is a there will be a flood or drought. Still, it may not be 100% correct. Okay, so but we can predict. Okay, there is chances of flood, we can relocate the people, or if it is a drought, the care should be taken. Okay, so mainly this subject deals with these things. Okay, here another one is climatology. Okay, and until unless you study about the climate, you cannot predict the precipitation. Precipitation means rainfall. Okay, so it is a science dealing with the study of climate over a given area within a specified period of time. The climatology means you cannot predict the climate of whole country, right? Okay, it will be different. Okay, for a specific area, already they are divided as specific areas based on that climate. Okay, so study of those areas, okay, we call it as climatology. Okay, for example, if you take a Bijapur city, it is an area. Okay, city. Okay, so climate may be change at one location to another location, so that's why we have divided into the different areas. Okay, for example, if you take Bijapur city, we can predict the climate, how exactly it should be. Okay, I think you might have seen the Google, there you can check the next week data, right? Next week data, whether there is a uh, how exactly the climate is in tomorrow, in next week. Okay, so that you can predict whether you can predict the rain, as well as you can predict the climatic conditions, what will be the temperature. Okay, easily you can check. Okay, even in Google you can check what will be the tomorrow's average temperature, or what will be the tomorrow's precipitation, how much will be there. Okay, these things will be study. Okay, these things will get from the climatology itself. Climatology means a study of climate. Okay, next one is meteorology. It is a branch of science dealing with atmospheric phenomena and the basic laws of producing and controlling these phenomena. Okay, controlling these two phenomena we call it as meteorology. Okay, so these are all the basic definitions which we deal in the hydrology subject. Okay, now why exactly it is required, why exactly hydrology is required, that we must know. Okay, what he says, hydrology plays an important role in water resource and planning, such as for what. Okay, so for example, if you want to construct a bridge, sorry, if you want to construct a reservoir or dam, okay, there you must know from where exactly you will be getting the water. Okay, that you must know. Okay, the topography as well as the precipitation, again it plays a major important role while designing or while designing any of the reservoir or water retaining structures. Okay, so for example, here it is structural and hydraulic design. First we'll go for hydraulic design. How much will be the capacity? Suppose for example, if you are constructing a dam or a reservoir, okay, it's a predicted capacity is different, right? For example, from the water streams you are getting some amount of some cusecs of water. Okay, I think you might have heard about cusecs and cubic, right? Okay, some cusecs of water. Okay, but when you design for that one, what happens? When you design the water streams, okay, some amount of water you expected in that reservoir, but what happens if you are not predicted the rainwater which also added to the reservoir. Okay, that prediction mainly done on the precipitation measurements. Okay, I think you might have seen the rain gauges at different locations. In Bijapur also there may be a rain gauges at different locations. Okay, so rain gauges are one of the earlier one of the measurement instruments to use to find out the precipitation percentage. Okay, okay, I think you might have seen okay, different types of rain gauges. Okay, you might have heard also this much of rain is happened here. Okay, I think in news, okay, this much of rain is happened in Bijapur. Okay, or it is going to happen in Bijapur. Okay, like that you might have heard, right? So mainly these predictions are done on the rain gauges or some graphical presentations. Okay, earlier data we will be taking. Okay, using those data we can predict the rain, how much exactly the rain may happen. It may not be 100% correct, but 90-95% you can predict the rain waters, right? Okay, now first major important is, okay, hydrology plays an important role to design. Okay, it gives the required data for structural and hydraulic design of the reservoirs or the water structures. Okay, so for example, here for any type of reservoir, spillway of sufficient capacity is most essential. Okay, so the proper capacity only predicted by hydrology. Hydrology means when you construct a reservoir, all data is required. Okay, precipitation, water from rain, water from streams. Okay, everything will be taken into consideration. And next one, second one is, okay, mainly again municipal and industrial water supply. Okay, again hydrology plays another important role for domestic water supply also, municipal as well as industrial water supply. Okay, until unless you predict the rain as well as it's like the subject is purely like a water management, right? So municipal and industrial water supply. Okay, these things will study based on the hydrology itself. Okay, and next one, irrigation. How much exactly irrigation water is required? Okay, how to manage the water? Okay, you know, at one location there is a huge rain. Okay, that is there is a flood. At another location there is a drought. Okay, so these things to be managed. Okay, these things to be balanced based on the irrigation balanced okay, by providing the irrigation projects or irrigation canals. Okay, I think you might have seen. Okay, at Kolar we have the water treatment plant, but it is distributed to the entire city, entire Bijapur city. Okay, because at the city, at Vijaypur city, we don't have any water resources. Okay, now we got one or two water resources. Still, you cannot use. Okay, there is no such arrangement have done. Okay, this for whatever the reservoirs are there in Bijapur. Okay, those are filled with the river water itself. Okay, so whatever the water we have, these are all okay. The water is brought and made a reservoirs, artificial reservoirs in Vijaypur city, but the natural resources is there in Kolar itself. Okay, we are getting water from Kolar. This we call it as a water management. Okay, whatever water we drink and we use, okay, that water is from Kolar water treatment plant itself. Okay, so there is a jack well. I think you might have seen. There is jack well. We lift the water from that is backwater of Krishna river. Okay, so we'll use those water and we'll purify and we'll use. Okay, this we call it as, again, to Krishna river we'll be getting water from the rainfall itself, the precipitation itself. Okay, so this we call it as the management, irrigation as well as power projects. Hydrological studies are essential for hydel projects. The Almaty dam is a multi-purpose dam. It is made for irrigation as well as hydropower as well as drinking purpose. Okay, the domestic purpose. Okay, multi-purpose dam is there. Okay, even until unless you study about the hydrology, you are not supposed to construct the Almaty dam, right? Okay, so purely depends on the hydrological or hydrological data, or we call it as what hydrological studies. Okay, mainly essential for these many projects. Flood control, obviously flood control and navigation. Okay, the flood control is also another major important role. Okay, as you can predict the rainfall, okay, you can control the flood at some extent. Okay, still many floods are controlled. Okay, actually there is a warnings will also be there. I think even last week we have seen the huge rainfall in Vijaypur city, but before that rainfall, earlier 2-3 days we got the warning of the rainfall, right? The same happened. Okay, so based on that we can control the flood. Okay, based on the hydrological studies we can control the flood. Okay, and next one is navigation. Okay, what happens mainly the soil okay, the navigates as well as what you call, okay, it involves hydraulic computations again. Okay, so however stream carrying sediment pools, okay, for example you'll uh, what dig out the sand, right? Okay, you'll mine the sand from river sides. Okay, it all mainly depends on what the hydrological studies also. Okay, erosion control, you can, I think you might have seen the stone pitchings. Okay, if there is a erosion of soil in any of the reservoir, okay, you can go for stone pitching. Like, okay, every study, okay, until you study the water you cannot find out the solution for that. Okay, so and pollution control, many parameters are there. Okay, we should go for this, and we must study these things. Okay, and apart from that, okay, as I said, it is a study of water, only study of water, right? Okay, we must know actual data of global water distribution. The total water available on the earth is around 140 into 10 to the power of 16 meter cube. Okay, out of that 97% is contained in ocean and sea as a salt water. Only remaining 3% is a fresh water. Okay, so oceans total data it is there, just go through that. Oceans, total area of oceans is 361.3 10 to the power of 6 kilometers square. Total volume of water is this much. Percentage is 96.5. Groundwater, it is in fresh state. Okay, 96 point, again oceans and seas are with 96.5, exactly 96.5% of water in it, and groundwater, that is fresh water, is again in groundwater, how much it is? Fresh water which is which can be usable, that is 134.8. Total area is 134.8 10 to the power of 6 kilometer square. Its volume is this much. Percentage of total water is 0.76. Whereas in a fresh water, only again in a fresh water, that is of 3.5%, only 30% of that can be used. Okay, and remaining things is saline, it is soil moisture, polar ice. Okay, the fresh water is in polar ice, that is 68.6% is in polar ice, and other ice and snow, it is 1%. Okay, so out of 3.5%, again out of 3.5% of total water, okay, only 30% of that 3.5 is remained for use. Okay, that is fresh water which we can use. Okay, so these are again the split data: fresh water, saline water, marshes in lakes, marshes, rivers, biological water. Okay, hardly very less percentage is there. Okay, again the fresh water is divided. Okay, it is the details from World Water Balance and Water Resource of the Earth of UNESCO data from 1978. Okay, present data may be different. Okay, you know what are the water resources of India are there? It is fact that Asia's water supply is the lowest, with an average annual runoff of only 17 centimeters. However, India is placed at is well placed with 16.83 into 10 to the power of 11 meter cube, running of a total area of 369 million hectares, yielding an over runoff of 457 mm. Okay, these are all the data which you can see. Whereas, what is the water potential of India? That is mainly rivers in west flowing rivers. The rivers which flows in west direction, that is in Kerala and Tamil Nadu. Okay, it is Tapi and Narmada. Okay, it is of this much cubic meter of water potential. East flowing rivers, that is Kaveri, Mahanadi, Ganga, Godavari, Krishna, Pannar. Okay, this is water potential of this much. Indus Valley or Indus basin, it is this much. Ganga basin, Ganga again it is divided. Ganga basin means it comprises of different rivers: Chambal, Yamuna, Ramadurga, Gomati, Garga. Okay, main Ganga. Okay, these rivers comprises of this much, and Brahmaputra and Barak basins. Okay, these are all this much of water potential in cubic meter. The million cubic meters. Okay, this will be obviously the river water is cannot be consumed directly, but it is treated. Okay, these are all the fresh water. We treat it as the fresh water. Okay, data of fresh water. Okay, surface water potential of India. Surface water means it is above the ground. And runoff data. Okay, as it is it is it will be on surface. Okay, so apart from that, there is some water will run off to the seas also, that is river falling into Arabian Sea. The catchment area is 1000 kilometer square. Okay, runoff in centimeter 63 centimeter. Okay, Indus basins, rivers falling into Bay of Bengal, Ganga system. Okay, Brahmaputra. Okay, these are all what happens when at the end the rivers will meet the sea. Okay, again we call it as the runoff data. Okay, these are all the simple data, just go through that. Until unless you know the history, you cannot create a future, right? Okay, so you must know these things. You know, practical application, we'll discuss on the practical application. As I said, it is classes at 11:50, only 18 members are watching. Even I shared a link in groups. The main practical application of hydrology is it is used to estimate. Just read out. Hydrology is used to estimate the probable maximum flood at a proposed site of dam and bridge, etc. Okay, as I said, we can predict the flood at dam, whether we should open the gate or not. Okay, it mainly depends on flood, rainwater, as well as runoff water to the reservoirs or dam. Okay, now the second one, the variation of water production from catchment can be calculated and described by hydrology. Okay, so how much will be exactly the catchment production? Catchment production means, suppose if you have constructed a dam or any reservoir, you can predict what will be the water level or what will be the water storage at years or at the position. Okay, we can predict the water, how much it will be, how much required, whether it is a over or whether it is a flood or drought. Okay, you can predict based on the hydrology. Okay, engineering hydrology helps in determining relation between catchment, surface water and groundwater resources. Okay, as I said, it is simple. Engineering hydrology helps between catchment, surface water and groundwater resources. It only studies about how much will be the catchment area that is stored and how much will be the water in the rivers. Okay, river or water streams. Okay, the expected flood flows over spillway at an highway, culvert or urban. Okay, for example, if there is a flood, chances of flood are there. Okay, you can easily predict. Okay, that can be predicted earlier also. Okay, hydrology help us to know the required reservoir capacity in order to assure adequate water for irrigation and municipal water supply in drought condition. Okay, as I said, if it is a drought, hydrology helps us to know the required reservoir capacity in order to assure. For example, if this time is a drought, okay, if this time is a drought in any of the water source, okay, you cannot avoid the water supply to the cities as well as for irrigation. Municipal water supply you cannot avoid. Okay, there may be a variation, but zero water supply, it will be a difficult one. Okay, so here what happens, adequate water for irrigation and for domestic or municipal water supply can be predicted if there is a drought condition. Okay, that means predicted earlier. Okay, prediction means it will be done earlier itself. Okay, and we can take the necessary actions. Okay, so hydrology helps us to find out the drought condition as well as helps us to take the necessary action. It also helps us to study about the flood condition and take the necessary actions. Okay, so hydrology helps in designing river training works. Okay, obviously whatever the study we do hydrology, okay, that mainly give a data for design of as I said, dams, canals, reservoir, whatever it will be. Okay, so and dependable yields from stream from generation of hydroelectric power. The same thing, whatever. Okay, the whole study mainly gives us the idea to find out yields, township and the water supply, water resources and river basins, operation of reservoirs, how it would be done. Okay, everything will depends on the hydrology, right? Now now hydrology and precipitation, again necessary of hydrological data. Why exactly the previous hydrological data or hydrology are required? Okay, where is most essential commodity of preserving and maintaining plant and animal life. With the advancement of civilization, the demand of water keeps on increasing. Okay, as the population is increasing, industries are increasing. Okay, the water demand is increasing day by day. Okay, this can be studied under the major headings, that is consumptive and non-consumptive use. Okay, so purely to study these things, always the hydrological data is required. Water used for irrigation is okay, now we'll discuss what is consumptive and non-consumptive. Okay, water used for irrigation is consumptive use. Okay, once you take water, it used for irrigation, it cannot be get back, since almost entire quantity is utilized, expecting very small portions reaching the sea or ocean as a groundwater. So when you use water for irrigation, some portion is used, some is what it is treated as the groundwater. Okay, it will be gone to the groundwater. And water running through hydraulic turbines is a non-consumptive, obviously. Okay, when water runs through the turbine, what happens? It will not, turbines will not consume water. Only the water, whatever the force in the water will rotate the turbine again. The whatever okay, when it work is completed, it will be again, okay, water is again it is added to the river streams or water streams. Okay, so it is, water is not lost here. Okay, it is non-consumptive use. Okay, consumptive and non-consumptive. Okay, mainly do these two portion of water is, okay, prediction. Okay, how much will be the consumptive use? For example, when I take water for water to run hydraulic turbines, the when it is completed, again that water is water can be used for domestic as well as irrigation purpose. There is no loss of water. Okay, and there is no energy, only its energy is lost. Okay, so water is not lost, only its energy is lost. Okay, he has mentioned only, okay, it may be a flowing energy may be lost. Okay, so other immediate types of industrial use to meet the various demands such as irrigation, water power and navigation, industrial use, etc. For example, some industries will use the water. Okay, later whatever the wastewater will be there, that will be treated, and again it is what again it is just left into the reservoirs or rivers, whatever it will be. Okay, industries will use water, treat, and later it will be left to the water streams. Okay, so again it is a, okay, if there is a losses, it will be treated as consumptive. If not, it will be treated as non-consumptive water. I think you might have known, you might have you know about the hydrological cycle. Okay, I'll show you. This is all about your hydrological cycle. Again, whatever the precipitation occur, okay, it is a, for example, first I'll start with the reservoirs or water streams. And percolation occurs, whatever the water is on the land is percolated and added to the water streams or water bodies. Later, under the sunlight or under that temperature, it is evaporation occur, evaporation into clouds, clouds to condensation and precipitation. Apart, when precipitation occurs, one is transpiration also occur and percolation. When these trees and all those things are there, when precipitated, some portion of water will be gone to trees, and some portion of the water from the trees that is evaporated, or this we call it as transpiration, and some portion, whatever excess portion is there, that is we call it as percolation. And the water is get percolated and added to water body. Okay, it is under the temperature, it is evaporated, again condensation under low air pressure, or okay, we call it as what less air pressure, that is chances of precipitation means a rainfall. Okay, and next one, this is the Hutton's cycle for hydrological cycle. This is Hutton cycle of hydrology. Okay, here you can see. Again, same thing is there. Actually, it is not quite visible. I'll send it to you. Okay, atmospheric moisture in transpiration and storage, precipitation, surface disposition and preposition, and next evaporation, again water. Okay, this cycle continuous. Okay, a small apart from this rain, okay, this precipitation means rain. Okay, we have written here. Okay, it may be in the form of hail, storm, and snow. Okay, all these are all the dew and frost. These are all the form of rain itself. Okay, this will be when precipitation or rain occurs. Okay, precipitation reaching the ground surface. Some portion will reaches the ground, and some portion, okay, just we'll discuss here itself. Okay, first thing I'll start with the rain itself. Sorry. Okay, so this will okay, fine. I think it might be visible, right? So I'll discuss this cycle. This is the rain. Okay, precipitation is occur. It may occur in these many forms. That is rain, hail, storm, sleet, snow, and dew and frost. These are the different types of precipitation. Whatever the rainwater or the water from these things occur, okay, it may be reaching the ground surface, or it may be evaporation during the precipitation. Okay, even the raining occurs during raining. During raining itself, there is chances of evaporation. Okay, the next one, precipitation intercepted and evaporated from the trees and vegetation. Whatever the water is there in the trees, on the trees, will be evaporated. Okay, that is another form of evaporation. Next one, another one is groundwater. First, direct evaporation on evaporation due to the trees, and remaining water will be on the ground surface. Okay, I think, and again in the ground surface, temporarily stored on the surface. Temporarily there will be a water. Okay, when rain occurs, there will be a water on the surface, as well as some portion of water will get infiltrated. Okay, there is again two things: infiltration. Whatever the water, temporary water stored on the surface is there, the surface runoff into streams. Okay, whatever the water is on the surface will may add to the water streams, or again it may be evaporated. Okay, when the water is added to streams, that is groundwater supply to streams, groundwater supply to ocean. Okay, when infiltration occurs, groundwater supply to streams, groundwater supply to ocean, and again it may be a direct evaporation. Okay, and groundwater supply to vegetation. Transpiration, again it is this cycle continuous. Okay, so I'll take okay, precipitation occurs. Okay, the rainwater occurs, direct evaporation happened, and some portion evaporation through vegetation, and some portion is runoff. Okay, that is reaching the water. Rainwater is reaching the ground. When it reaches, some portion of the water is temporarily stored on the surface. Water will remain on the surface, and some portion is infiltrated. Okay, this is seepage through the ground. Okay, that we call it as infiltration. Okay, that occurs. Again, in temporary or stored water on the surface, it may evaporation from the ponds. When the water is stored on any of the ponds and lakes and stream surfaces, okay, this will be again evaporated. And temporary stored water, again stored on the ground, it may run off. Runoff means the flowing water on the ground. Okay, we call it as a runoff. Next one is, okay, so infiltration occur. In infiltration, ground, okay, it will be infiltrated to the streams, groundwater supplied to the ocean, and some portion of the infiltrated water evaporated, and groundwater supply to vegetation. Groundwater recharge may occur, and some portion the infiltration occur at certain depth. Whatever the water flows, okay, the infiltration occur or runoff below the ground level. Okay, it will be recharged, or it will be taken into the oceans. Okay, and next one, some portion of the water in the ground is evaporated due to the temperature, and some portion of groundwater is supplied to the vegetation. Okay, whatever the trees vegetation is there, okay, that will be taken. And here temporary surface, when it is surface around water, outflow from the streams. Okay, water is added to the streams, outflow, again outflow to streams to oceans, ocean to again evaporation. Okay, here also groundwater supply to oceans, again this one, groundwater supply to streams, stream to ocean, ocean to evaporation, groundwater supply to ocean, ocean to ocean storage, and next evaporation. Next one, infiltration, evaporation, next atmospheric vapor, again evaporation, the clouds will occur. Okay, at the end this cycle will continues. Okay, at the end here groundwater supply to vegetation, again transpiration occurs, that is water evaporated from the ground, and next one atmospheric vapor. Later surface deep disposition of precipitation. Okay, next evaporation, next atmospheric moisture, it turns into clouds, again precipitation, and some portion is directly into clouds. Atmospheric moisture, it will remain when the evaporation occurs, it will remain in the moisture, again precipitation. Okay, this cycle continues. This is the Hutton's circle for the hydrology. Okay, is it clear? Please reply with the messages. Shadab, what thing you didn't get? All you studied this in the primary itself. बारिश कैसे होगा? How exactly rain occur? Okay. Okay, I'll explain once again. Here, okay, listen carefully. I'll explain once again. Okay, first, if there is a water on the surface, for example, I'll start with the precipitation itself. Okay, when the rainfall occur, okay, rain is precipitation or rain is in the form of snow, ice, or it may be a rain. Okay, so some portion of the water, rainwater, will surface runoff. Just go through this figure. Surface runoff directly, some whatever the rainwater or rainfall occurs. Okay, some portion of the water will flow, it will added to the water streams or lake. Okay, and some portion is infiltrated, some portion of water is infiltrated into the ground. Okay, due to infiltration there is a chances of the evaporation also. Okay, infiltration or percolation. Okay, when percolation occurs, this is a soft ground, you treat it as a soft ground, obviously the water is get into the soil or a ground. Okay, this we call it as percolation. And at the below there is a water table, or it may be a hard rock or water table where cannot where water cannot enter. If it is a ground water flow, what happens? Whatever the water which is filtrated, which will be again added to the groundwater through the percolation. Okay, so first one, the water is added to the lakes, that is surface runoff. The water is added through the percolation, that is after infiltration. The water is added to the lakes again for to the reservoir because of the water table, the same water table. Next one, the evaporation from this lake occur, and some portion of water is added to the vegetation. And next, from lake to rivers, river to oceans. Okay, the water is okay. And now at wherever you get the water is okay, here in a first, due to surface runoff, there is a chances of evaporation. From the lake there is a chances of evaporation. From the vegetation there is chances of evaporation. From the vegetation we call it as transpiration. Okay, transpiration may occur. Next, evaporation from the rivers and evaporation from the oceans. okay, due under the temperature due to sun. Okay, if these occurs, there is chances of cloud. When the cloud condenses, obviously again rain. Okay, when the cloud condenses, again the rain or the rain in the form of snow and ice may occur. Again this cycle continuous. Is it clear? Is it clear now? Is it clear now? Please reply whether it is clear or not. Okay, here you can see the cycle. Shadav, yes sir, got. Thank you. Okay, next. Any other replies? Khalil, fine. Khalil got the concept. Thank you. Next. Urtuza, fine. Okay, you just keep your name as it is. Don't write the Murtuza Gaming Addictive Zone. Okay, you have nice names, I think, right? You just keep as it is. Azhar Patel, fine. Sana Afrin, fine. Bhagya, right. Okay, Viresh, fine. Okay, next I'll proceed. Okay, this is all about the hydrological cycle. Again, you just read out what is evaporation and transpiration. Okay, we'll read out one by one. Okay, evaporation and transpiration is due to sun radiation, the water from the surfaces of seas, oceans, rivers and lakes get evaporated, whereas the transpiration is the process of water getting lost from the plants and vegetation. Evaporation is from the river streams or storages, and transpiration is water lost from the plants and vegetation. And precipitation means it can be defined as fall of moisture from the atmosphere to the earth surface in any form of either liquid or solid. Okay, it may be a rain, snow. Okay, so this we call it as precipitation. Okay, when there is a atmospheric variation in the atmospheric pressure, there is a chances of these things. Okay, and next one is runoff. It is the portion of precipitation which makes way towards the runoff. Means whatever the water is precipitated which makes a way towards the sea or ocean, either as a surface or subsurface water. Okay, it may be a surface water or below the surface, whatever we call it as subsurface water. The surface runoff water flowing over the land and which reaches to the lakes or water storages. Interflow and subsurface runoff, it is a portion of precipitation infiltrating into surface soil and depending upon the geology of the place run as subsurface runoff and hence joins the stream and rivers. Next, groundwater flow or base flow. Okay, what happens? Whatever the remaining portion of water is there, is that portion of precipitation which after infiltration, whatever when infiltration occurs, it reaches its limit. Okay, whatever the water remains on the surface, we call it as groundwater or base flow. Okay, so percolates down and joins to the groundwater reservoir, ultimately connects to the sea and ocean. Okay, at the end will whatever the water is there at high altitudes, it will reach its water table or the sea or river. Okay, now the precipitation is nothing but precipitation is equal to R plus E plus S. R is surface and subsurface runoff. E is the total evaporations and surface and subsurface storage of water. Okay, together we call it as the precipitation. Okay, this is the Hutton's hydrological cycle. Already we have discussed here, right? Is it clear? These are all the definitions which we will study. Simple things are there. What exactly runoff is there? Okay, precipitation, evaporation, transpiration, groundwater. Okay, interflow or subsurface runoff. Okay, these simple things are there, just go through that. Again another cycle is there. Attention representation of another representation. Just atmosphere, precipitation occurs. Okay, here another representation of atom representation is there. Here it is atmosphere. From atmosphere there is a precipitation on the land surface, infiltration to the soil, and next to the aquifers. Next one, there is a chance of predict snowfall, and okay, that will melt again land surface. Okay, and some of water is to the vegetation. Again from the vegetation it will be evaporation. Okay, next one, some land surface water is into the storms, and soil water is also, or soil moisture is interflows and which reaches the storm, and from the aquifers the water is reaches to the oceans. Okay, again from oceans evaporation. Here it is evaporation from the rivers, and it is transpiration or evapotranspiration, we call it as evapotranspiration. Okay, so this will occur again, added into the atmosphere, clouds, again precipitation. Okay, this cycle continues, right? Is it clear? Is it clear? Please reply with the message. Is it clear now? But I am very disappointed that only 17 or 16 or 17 members are there. Okay, from B division. I expected more strength from B division, as it is of. Okay, I need to complete because internals are also there, right? Venkatesh, okay, yes. Viresh, yes. Khalil Ahmad, Shadab, Tanvir, Ashwini, Sandeep, fine. Okay, next is these definitions. Okay, just go through these definitions, just read out. Okay, I'll share you the notes. Formation of precipitation. How exactly? Just go through these. Rainfall intensity. Okay, express depth of units. Okay, some definitions, simple definitions are there. What is rain? Snow, storm, priming rain, rain storm, rainfall intensity, point rainfall. Okay, every definitions are there. I am not supposed to read out these things. Okay, whatever things are there, I'll share. Okay, just understand yourself. Next, formation of precipitation. Okay, how exactly it happens? The condition of precipitation to take place may be as follows: supply of moisture, cooling to below point of condensation and growth of particles. Okay, the rainfall how occurs? The supply of moisture. Okay, if there is atmosphere change in atmospheric pressure. Okay, there is a condensation occur. Condensation reaches to the process of precipitation. Okay, precipitation process. How exactly the rainfall? Atmospheric water vapors in source of precipitation. Okay, as I said, atmospheric pressure variation occurs, or okay, because of that condition the rainfall occurs. Okay, how exactly the condition is? A liquid droplet or ice crystals grows to visible size through diffusion of water vapor. Okay, there is a intact, the cloud is a intact particles of the water vapors itself. Okay, when it condenses the rainfall occur, right? Forms of precipitation. Okay, now we'll discuss on the forms of precipitation, that is drizzle. Drizzle means these are the water drops which is less than 0.5 mm in diameter and the intensity is less than 1 mm per hour. Okay, drizzle means just it's like a particle size of that water droplets is very less. It is 0.5 mm. okay, and its intensity of total rainfall is 1 mm, only 1 mm per hour. Okay, so rain is, these are the water drops which are more than 0.5 mm and less than 6 mm in diameter. Okay, if the size of rain droplets is more than 0.5 mm and less than 6 mm in diameter, these will be treated as the rain. Okay, then light rain is 2.5 mm per hour, moderate rain 2.5 to 7.5 mm per hour, and heavy rain is more than 7.5 mm per hour. Okay, earlier last week we found uh, what rainfall of around 20 mm per hour. Okay, last week 4 5 days back we got in Bijapur city, we reached 20 mm per hour. That means it acts as a heavy rain. Okay, so it treated as the heavy rain. Okay, now glaze, it is the ice coating formed when drizzle or rain freezes as it comes in contact with cold objects to the ground. We call it as glaze. The sleet, it is the frozen raindrops cool to the ice stage while falling through the air. It is sub-freezing temperatures. Okay, sleet. Next one, snow. It is the precipitation in the form of ice crystals. Okay, when the water vapors directly becomes ice, it has an average density of 0.1 gram per cm cube. And snowflake, it is a ice crystals fused together to represent snowflakes. It is the precipitation in the form of ice balls or lumps. Okay, again after rain, I think we have 4 or 5 different uh, types of rains are there which we cannot differentiate properly. Okay, there is no such sizes and something he has not given. Okay, it is precipitation in the form of ice balls, lumps whose diameter is more than 5 mm. Okay, the 5 mm, more than 5 mm lumps are there, that we call it as the hail. Okay, these are formed by alternate freezing and melting as they are carried up down in a storm currents. Okay, what you call the hailstorms means what the ice of size of more than 5 mm will occur in the fog, okay, during rainy seasons. Okay, this we call it as hail. You cannot treat it as rain. Now the types of precipitation. There are 3 types of precipitations are there. One is convective precipitation, orographic precipitation, and front lifting. Okay, and cyclones and convergence. Okay, these are 5 different types of precipitations are there. Okay, we'll discuss these in next class. Okay, I may take I'll take class at again in once again in evening. Okay, ask your friends to join that class. Okay, so that I can complete first module by tomorrow. Okay, thank you.
Thank you, sir.